Hello, ladies and gentlemen. Today we are going to take a look at the cone. So how does surface area and volume change, or how does that work when we're talking about a cone shape? So remember with the cone, we're talking about a circular base and the curve sort of meets at that point at the top. So it's like a curvy pyramid, if you will, a circular pyramid. So when we talk about cones, the same terminology and the same labeling is pretty consistent with what we would see for a pyramid. We have this down here as the base. The base now happens to be a circle. And we still have that slant height of the cone, just like we have with a pyramid. And we have the straight up and down height here of that cone, just like we have with that pyramid. So some of the things that we're looking at are very similar. How can we then extend what we already know to cones based on what we know from pyramids? So again, just to reiterate the vocabulary, we have this vertex at the very top. We have this height again. The lateral surface is still the surface that's on the side. We have a base on the bottom, that slant height you see. And using all of our previous knowledge, we should be able to take a look at the cone and sort of dissect it in terms of its surface area. So this is what the cone would look like if we took it apart. We'd have that circular base, and then we'd have this, sort of crazy curvy triangular piece then for that lateral side or that lateral surface. So how can we adjust our formula then? Well, remember with the surface area of a pyramid, we had surface area equals area of the base plus 1/2 perimeter times the slant height. Well, with a cone, all we're really talking about is this base now is a circle. So if I substitute in the formula for the area of the base of a circle here, if it's a circle, it's pi r squared. And then I'd have 1/2 perimeter of the base is perimeter of the circle down here. And perimeter of the circle is 2 pi r because we're talking about its circumference. And the slant height is still going to be fine. That's okay. Now if I look at simplifying what I have here, I have pi r squared. And if we did take 1/2 times 2, that would just make 1. So it's like we're saying we have pi r squared plus pi rl. So if I was going to simplify the formula and try to make one single formula for the surface area of a cone, this is what it would look like. Remember, it comes from what we know about pyramids. All we're doing is now changing that base into a circle and inserting the appropriate formulas. So how can we use it then to find surface area? Well, let's take a look at what we have here in this cone. We have 5 for the radius of the cone, and this 12 is the height. You want to sketch a picture of that. And now let's go ahead and use our surface area formula. Surface area formula says we have pi r squared plus pi rl. And now to plug in the values we know, the radius is 5. So I'm going to plug that in every place I see an r. What about the L? What about the slant height? Well, we don't know that on this cone yet. This guy right here would be that slant height. We need to calculate that using the Pythagorean theorem. So we'd say 5 squared plus 12 squared equals L squared. Remember, the L is the hypotenuse in this case. So we have 25 plus 144 L squared. This would be 169 L squared. Square root it, and the slant height is 13. So we know that slant height is 13 right here. We can go ahead and plug that value in. Now, if you wanted to leave your answer in terms of pi, we could say that we would have 25 times pi here. Oops, 25 pi. And on the other side, we'd have 5 times 13 here. 5 times 13 is 65, so we'd have 65 pi. There should be a plus sign in between there. And so now if we add 65 plus 25, we end up with 90 pi. So the total surface area for this cone is 90 pi. Now again, if you wanted to turn these into decimal values, that's fine. We'd have pi times 5 squared, find that value, pi times 5 times 13, find that value, and then just add those values together. But if you want to leave your answer in terms of pi for surface area, that would be fine. So in decimal value, if you want to approximate this is 282.74. And we would label that with centimeters squared because we're talking about surface area. Okay, now how can we adjust our formula for volume then? So using our previous knowledge when we talk about cones and their volume, we're going to revert back to what we already know about pyramids. And pyramids have a volume formula of 1/3 area of the base times the height. So 1/3 area of the base times the height. The only thing that changes is the base right here is a circle. So we have to insert pi r squared in there. So my formula becomes 1/3 pi r squared times h. Or again, you can also take pi r squared times h and then divide it by 3. That would be the same thing as multiplying by 1/3. All right, so let's do one volume example here. Find the volume of the cone, round to 2 decimal places. So we have this cone here. It looks like he's labeled in feet. We have a radius here of 5. We have the slant height given as 13. So we can go ahead and find that volume. Volume again is 1/3 pi r squared times h. So 1/3 pi, the radius would be 5 squared, and now h is the height of the cone. We don't know that. That's this measurement. That's different than the slant height. But I can again use Pythagorean theorem to find that because I see I have a right triangle here in my diagram. So we'd say 5 squared plus h squared, because those are the two legs of the right triangle, equals the hypotenuse squared. So 25, h squared, 169, h squared. When you take 169 and subtract 25 from it, you get 144. So h would be 12 when you take the square root. So we have the h measurement of 12. So if I was going to calculate this volume-wise, you can go ahead and type in pi times 25 times 12 and then divide that answer by 3 and get that decimal value. We can also calculate 5 squared is 25 times the 12 and do the 1/3 and just sort of leave that pi alone so we can come up with an answer that's left in terms of pi. So we'd have 300 if we multiplied these two. This is 300. 1/3 of 300 is 100. So we would have 100 pi as our volume answer. Okay, so 100 pi would be how I'd leave that in terms of pi, but you can also use the decimal approximation. In fact, in this case, it says round to 2 decimal places. So it's saying that we actually want that decimal answer. So I would have 314.16 feet cubed because we're talking about volume. Okay, so this is the formulas that we need to worry about with cones, volume and surface area, and it all hinges on our understanding of how pyramids work. Okay, so I want to thank you, ladies and gentlemen, for taking good notes. I'll see you later. Kincaid out.